Good morning, dear students. Let's start the topic, that is galvanometer. So galvanometer, it is what? It is a device that detects current in a circuit. That detects current in a circuit, as well as it defines the direction of the current in a circuit. So what does it mean? First of all, it detects whether the current is flowing in a circuit or not. Second thing, it also defines that in which direction the current flows. Means whether from terminal A to terminal B or from terminal B to terminal A. So galvanometer, these are two types. Galvanometer, let me write. Galvanometer on the basis of the position of magnet and coil. So on the basis of the position of magnet and coil, galvanometer, these are the two types. One is one is moving magnet galvanometer, and the second one is moving coil galvanometer. Moving coil galvanometer. And from the name of these two, we may tell that here the magnet moves and the coil becomes steady. And in this case, the coil moves and the magnet becomes steady. So further we will discuss about moving coil galvanometer. So all of you note it down. Now let's proceed. Moving coil galvanometer. It is of two types. One is suspended coil. One is suspended coil galvanometer, and another one is pivoted coil galvanometer. In this case, the coil is suspended suspended means hanged, suspended by a string, or where in between the two poles of a strong magnetic field. Okay, so in this case the coil is pivoted. So pivoted means what? Pin up at the center. The coil is pivoted with an attached spring, in between the two poles of a strong magnetic field. Okay, so this is about the type of moving coil galvanometer. In both the cases, the coil moves and the magnet becomes steady. So let's proceed for this type, that is pivoted coil galvanometer. Generally, we are using in the laboratory, that is pivoted coil galvanometer. So let us discuss further. All of you noted down. So let's discuss the pivoted moving coil galvanometer, its construction. So basically, the main parts of this is what? Number one, strong magnetic field. Then number two, coil. Number three, that is spring attached to the coil. And number four, it is scale. So strong magnetic field, coil, spring attached to the coil and the scale. These are the main components of the pivoted moving coil galvanometer. So here what happened, in between the two poles of the magnetic field, here is the coil that is wind up on a aluminum plate, and this is pivoted at the center, and they are pivoted on this rod. Okay, so this rod, it is connected to spring. Here are the two nails, all of you see here, and when it rotates like this, okay, in this way or in this way. So when it rotates like this, then what happens? There is the spring gets contracted. स्प्रिंग क्या हो जाता है? कंट्रैक्ट हो जाता है, मतलब स्प्रिंग वाइंड अप हो जाता है. ओके, and when it come to its original position, in the absence of current through it, then what happened? It again relaxed. The spring becomes relaxed, means again it returned to its original position. So the situation we will discuss about. So all of you draw this diagram and note it down. So let's continue. First we have to know the theory or principle. So principle of this pivoted moving coil galvanometer is that when current passes through the coil, when current passes through the coil, there will be a force applied, there will be a torque, there will be a torque applied on the coil. Torque applied on the coil. So this is the principle, because the coil is in the magnetic field, and when the current passes through the coil, then what happens? Due to the magnetic field and current, there is the application of the force according to left hand rule. If it is the magnetic field, it shows the magnetic field, direction of magnetic field, and it shows the direction of current, then it will show the force applied on the coil. Okay, so let's proceed further. Now working process. Now working. So how it works? So let's discuss. When the current passes through the coil, when the current passes through the coil, then a torque is applied, on the coil, that is tau is equal to NIAB, where N number of turns or loops of the coil, then I, current, passes through the coil, and A, it is the area of the coil, and B, it is the magnetic field magnetic field. Okay, so this is when the current passes through the coil, then what happens? There is the application of torque, and what is the magnitude of the torque? That is NIAB. It means the coil will start to rotate about its axis. Then what happens? So when coil starts to rotate about its axis, when coil starts to rotate about its axis, then there is a deflection, then there will be deflection on the pointer on the pointer on the pointer attached with the coil and shows the reading of current in the coil, in the scale, current on the scale. Okay, so this is related to pointer. Then next is when the torque is applied on the coil at the same time on the coil at the same time or restoring coil or restoring torque is produced is produced uh, in the spring attached attached with the coil, in the spring attached with the coil, uh, due to twisting of the spring. So actually what happens when there is application of torque, applied torque on the coil. Then when coil starts to rotate, then the spring attached with it, the spring start to wind up, means contracted. Okay. So the pointer will stop, means the rotation of the coil will stop when the applied torque will be balanced with the restoring torque in the spring. So let's start. Let phi is let phi is the twist in the spring. Is the spring, and K is the restoring torque, and K is the restoring torque, and K is the restoring torque per unit twist. Per unit twist. So the restoring torque will be equal to K phi. Okay. At balanced condition, balanced condition means what? When the restoring torque and applied torque both will be equal to each other, then the pointer will stop. Okay. At balanced condition, applied torque is equal to restoring torque. So that means what? Applied torque is what? That is tau. It is equal to K phi. So tau is what? NAIB is equal to K phi. So phi it will be I will be equal to K upon NAB phi. Okay. So this K, it is what? It is the restoring torque per unit twist. So K is constant, N number of turns is constant, area of coil is constant, magnetic field strength is constant. So this all totality is constant, and that is taken as G. So I is equal to G phi. So G is constant. So we may say I is proportional to phi. So here what happened? G is what? G is equal to K upon NAB uh, is called as a galvanometer, is called as galvanometer, is called as galvanometer constant, is called as galvanometer constant. And now here we find that I is directly proportional to phi. So what this statement means? So this statement means this statement means that the current passing through the coil, passing through the coil is directly proportional to the twist in the spring, to the twist in the spring. Okay, it means what? When the current increases, the twisting in the spring also increases. And when the current decreases in the coil, then the twisting in the spring decreases. Okay, so this is the relation between the current and the twisting in the spring, and twisting is related to the restoring torque in the system. Okay, so now we found that a current is directly proportional to phi. Next is it shows what? It shows that the galvanometer is very sensitive towards the flow of current, towards the flow of current. So let's talk about sensitivity of a moving coil galvanometer. So here are two types of sensitivity of a moving coil galvanometer. First one is current sensitivity. Okay, so before this, we must have to say, that the galvanometer is very sensitive towards current and voltage supplied to the coil. So what does it mean? it means uh, it means when when minimum when minimum current or voltage is supplied to the coil is supplied to the coil, there will be there will be greater deflection greater deflection uh, on the on the pointer. So how it is? Let's discuss how. When a minimum amount of current is supplied to the coil, this current is multiplied. This current is multiplied by the presence of n number of turns in the coil. uh, Actually, what happened? Actually, the same current, the same minimum current, minimum current is the same minimum current flows through each turn, through each turn, and the total current and the total current and the total current and the total current becomes total current becomes multiplied by the number of turns in the coil. And so for minimum and so for minimum current supply, and so minimum current supply, there will be greater deflection, greater deflection on the pointer, on the pointer. As we know that I is directly proportional to phi, where phi is the deflection or we may say twisting angle made by the pointer. Twisting angle is made by the pointer. Okay. So this is that why a galvanometer is sensitive towards the current. So like current, galvanometer is also sensitive towards voltage. So let's discuss one by one current sensitivity and voltage sensitivity. First, current sensitivity. Actually, what is this? It is the ratio, or we may say it is, it is the deflection, per unit current supplied, that is SI is equal to phi upon I. So let's find the expression of phi upon I or SI. We know that I is directly proportional to phi, and I is equal to K upon NAB phi, Then phi upon I is equal to 1 upon K upon NAV is equal to NAB upon K. So phi upon I is equal to NAB upon K, and that is equal to current sensitivity, and we will write here as SI equal to phi upon I is equal to NABK. So this is the current sensitivity and its expression. So now let's talk about voltage sensitivity. So voltage sensitivity, second, voltage sensitivity. Uh, it is the deflection. It is the deflection per. It is the deflection per unit voltage supplied. That is voltage sensitivity SB is equal to phi upon V. So let's find the expression of phi upon V. We know phi upon I is equal to NAB upon K. So phi upon V upon R is equal to NAB upon K, because we know that according to Ohm's law, V is equal to IR. So it's reciprocal. So it is R phi upon V is equal to NAB upon K. Now it will be R will be this side, R will come to this side. So phi upon V is equal to NAB upon K. Phi is equal to phi upon V is equal to NAB upon K multiply 1 upon R. So it means what? SV is equal to phi upon V is equal to NAB upon K multiply 1 upon R is equal to SI upon R. Because current sensitivity is NAB upon K, so it will be SI upon R. So voltage sensitivity is equal to current sensitivity upon R. Voltage sensitivity is equal to current sensitivity upon R. Okay. So reciprocal, so R will be here. Okay, it's correct. Now It is voltage sensitivity and current sensitivity, the relation. Now let's try to discuss the dependency of the sensitivity of galvanometer. मतलब galvanometer का जो sensitivity है, current sensitivity and voltage sensitivity, on what it depends upon. So all of you note it down up to this. So let's talk about the dependency of the sensitivity of a moving coil galvanometer. As we know from before derivation that SI is equal to NAB upon K, or SV is equal to NAB upon K multiply 1 upon R. Okay. So it means what? Sensitivity of current or voltage. Sensitivity of current or voltage depends on number one, N. That is, depends on N. That is number of turns should increase for higher sensitivity. SI is directly proportional to SI, or SV is directly proportional to A. Next is A, that is area of coil should increase. Area of coil should increase. SI or SV directly proportional to A. Third one, magnetic field, that is B, magnetic field should be stronger, as SI or SV directly proportional to B. Okay, and so here are the three dependency of the sensitivity of galvanometer. That is, number of turns, area of coil, and magnetic field. And it also depends on the K. What is K? K is what? Number 4, that is K, that is K. K is what? That is the restoring torque. Restoring torque should be restoring torque should be less. Restoring torque should be less. Why less? Because SI or SV is inversely proportional to K. And the fifth one is R, that is resistance of the coil should be decreased. That is SI or SV is inversely proportional to R. So this is all about the sensitivity of moving coil galvanometer and its dependency. So have a good day. We'll meet again. Thank you.